Hello Internet, my name is Jacob. I'm a data scientist and a web developer in Toronto. I recently got a Raspberry Pi and a Sense hat and I've been playing around with them and I want to show you some of the stuff I've done, hopefully to inspire you, as well as just to showcase my work. So for those of you who don't know, the Raspberry Pi is just a miniature computer. It's great for anybody that's interested in getting into robotics because first of all it's cheap. And second of all, it has these GPIO pins that you can then connect any kind of additional hardware and sensors to, and then write whatever logic you want to go with those sensors and that hardware. So one of the sensors I've got is what's called a Sense hat, which is a chip that was designed specially for the Astro Pi mission in 2015. It comes with a 6 essential sensors, as well as an 8x8 LED matrix here, as well as a joystick. So I've decided to try and program a simulation for an airplane's control system, because this thing has on it an accelerometer, a gyroscope, a barometer, a hydrometer, a thermometer, basically all of the ohmmeters. I thought that this was the perfect, airplane's control system was the perfect project. So all my code here is on GitHub. Feel free to clone it and do anything you like with it. I'm just going to show you how it works here. Once you've cloned the code and you're navigating into the root directory, run Python 3 on the root Python file, and you should be able to navigate into localhost 5000 on your web browser and see the simulation here. So like I said, the Raspberry Pi has on an accelerometer and a gyroscope. So the main thing to take notice of here is that in the center of the screen we have a very primitive looking model airplane. We can spin the view around to look at this model airplane from any different angle we like, maybe zoom in on the belly, look at the top, look at the wings, whatever we like. But what's unique about this from just being a 3D model is that it moves in live time in connection with my Raspberry Pi. So as I tilt my Raspberry Pi on the y-axis here or on the x-axis like this, you can see the model airplane in the view is reacting in live time to the movements of my Sense hat. That's due to the readings that are coming from the accelerometer and the gyroscope. There's also a couple other stuff you can see going on in the top left-hand corner here. I've got the compass readings going on. They're again updating 10 times a second, telling me my degrees north. I've got humidity, which is telling me the humidity of the room in percentages. You can see as I breathe on my Raspberry Pi that those humidity readings go up nearly 10% and are slowly falling back down now. So this is pulling real physical data in real time and rendering it on the view. We've also got air pressure in millibars. And I think that's one of the things that's actually impressed me most about the Raspberry Pi is the accuracy of the barometer. Even from just like upstairs to downstairs in the house here, it's able to notice a difference in air pressure. The temperature readings are always a little bit higher than what's expected. I think that's because the thermometer that's on the Sense hat is so close to some of the other electronics, like the CPU, which is heating up and whatnot. But there you go. You've got your accelerometer, your gyroscope, your compass, your hydrometer, your barometer, and your thermometer, all rendering data in real time on the screen there. Now, one last thing to show you is that not only did I want to be able to read data from the physical world and render it in real time on a view, but I also wanted to have the interactivity for somebody who's using the view to send data back to the physical layer. So I added one more feature here that I'm calling comms. So you can type in any message you like in the box here, just like hello, hit shift enter, and it will send it back to the Raspberry Pi and it will scroll across the LED matrix there. So that's just sort of an example of how you can program a Raspberry Pi to simulate an airplane's control system. Those outputs could be anything you want. I've only got messages scrolling across an LED screen, but whenever you type something on the view, hit a key, press a button, pull a lever, the output could be anything from putting down the landing gear to turning on the seatbelt sign or anything like that. So if any of you are interested in robotics or just like aviation freaks, geeks, you think this is cool, yeah, I'd love to know what you think about it. Check out the code on GitHub and give me your feedback. Thanks.